Hello everyone, we are from Group 4 going to present about design of glider using composite materials. There are 5 hours. Before we begin the presentation, we like to thank our lecturer, Professor Dr. NORKHAIRUNNISA MAZLAN.
Assalamualaikum and a very good day to Dr. Khairunnisa. My name is ABDULLAH HANNAN bin SHAMSUDIN and my matrix number is 207297.
Bismillahirrahmanirrahim. Assalamualaikum and a very good evening. My name is FARAH ZULAIKHA binti JAFRIKHAIRI, matrix number 207785.
Hello everyone, my name is FARHAN and my matrix number is 204801.
Good evening everyone, my name is GANESH and my metric number is 206116.
Salam and greetings to Dr. Nisa and all. My name is NURIN SYAZANA binti HAMID and my metric number is 207071.
Let's get started. So the title of our project is the design of glider using composite material. So before that, we are going to go through about the presentation outline. So we're going to start our presentation from the introduction, and then after that, we will moving on to the methodology and design. And then thirdly, we're going to cover about the design function and specialty. After that, we're going to explain about the benefit of design. And last but not least, we're going to cover about the environmental effect of the design. So what is a glider? A glider is an aircraft which totally dependent on the reaction of air in the atmosphere. So it shares the same aerodynamic concept with a normal airplane, except there is no thrust because there is no engine. So the dominant characteristic of a glider is the huge wingspan, and then the parts of glider is the same as an aircraft. Moving on to the methodology. So we started our project by researching through the internet, because that's the only resources that we can refer to because of COVID-19 circumstances. So once we collect all the data, we discuss which the design is the best one. Then we will present the results on the report and on the presentation.
For our glider's design, we decided to choose the tapered shape wing design. This design creates less drag compared to common rectangle shaped wing. As for the wing ratio, our glider has a high aspect ratio which will generate a comparatively high amount of lift with less induced drag at a low angles of attack. Moving on to the next part, which is the material selection. For the material selection, we choose bamboo fiber epoxy resin composite as the glider skin. This is due to the advantageous properties of this natural fiber composite itself. Bamboo epoxy resin composite has a high tensile strength, high impact strength, and also a low ductility. These three characteristics will make a good material to cover the external part of the gliders. That's all for me. Now we'll pass on the presentation back to Hannan. Thank you.
Now I'm going to present about the material selected for the glider structure. So we have already decided to use carbon fiber composite for the glider structure, mainly on the wing and the fuselage of the glider. So the reason why we choose it because of its fantastic mechanical properties. So the first one is it contains a very high tensile strength, ranging from 391 megapascal to 713 megapascal, and then it contains a very low density material, which is a lightweight material, so it only contains 1.4 gram per cubic centimeter of weight. So both of these properties combined will be a material that contains a high strength to weight ratio. And then after that, carbon fiber have a low thermal expansion coefficient, and last but not least, it has a high fractural strength, which is 304.81 megapascal.
Thank you very much. So I'll be presenting the specialty of our glider's design, as you can see. So this is the upper view of our glider, which includes the air brakes, fuselage, and aileron. And this is the side view, which includes the cockpit, nose wheel, landing gear, tail wheel, horizontal stabilizer, elevator, and rudder. This is the front view. We can see the horizontal stabilizer, the cockpit, and the winglets. The winglets helps us to reduce the drag. Actually, the whole glider design is made by the manufacturer so that it's aerodynamic and the drag force is decreased. But the specialty of our design is the materials that we have used, which includes bamboo fiber. So Right now, bamboo fiber is used for the gliders, skins such as the wings and the fuselage, and carbon fiber is used for the structure. These materials are being used because the glider to make the glider greener and easily to decompose them. Carbon fiber is used because it is safe, strong, and light, and bamboo fiber is used with epoxy resin so that the material is strong. So this is my part of the presentation. I'll let my friend to continue the rest of the presentation. Thank you very much.
Now it's about design functionality. Our glider mainly made up with bamboo fiber and carbon fiber. These materials are lightweight materials and the weight is distributed at its strategic point in an efficient manner. Next, the gliding ratio for this glider can be between 40:1 to 70:1, which means the glider can fly for 40 to 70 kilometers if it starts flying from 1 kilometer high. To gain altitude, our glider depends on three main phenomena, which are the thermals, race lift, and wave lift. Our glider is made up of light materials, which is more efficient to gain altitude by thermals. Sometimes there is a possibility for the glider to face an impact, so the glider's frame and stringers are made up of carbon fiber, and also the body skin is made up of bamboo fiber, which is really strong and stiff to withstand the impact. Next point is about the wings, which is really thin and generates less aerodynamic drag. The wings also has high aspect ratio. Next, the factor that helps our glider for better aerodynamic is design of fuselage, which is why the pilot enters the cockpit in much the same way as Formula 1 driver in his car, almost lying down. So guys, in my opinion, this glider design works perfectly. That's all from me. Now I'll pass the presentation to NURIN. Thank you.
Okay, right now I'll be presenting about the benefit of design, which who will be benefit from this glider design. So the first one is the aerospace industry. So this glider's design will actually help the pilots with their proper training, especially in improving their basic flying skills and knowledge. So this material used in this glider design, which is carbon fiber composite, actually can influence the interests of people in the aerospace industry. Next, the bamboo fiber material that is used in this glider design too is able to reduce the tremendous energy consumption in aerospace industry too. So next, we move on to the communities. So this glider design will help the local farmers in generating their main or side incomes, especially in producing the bamboo fiber composite. So this glider design will help the inventors and manufacturers in choosing a low-cost materials, which is the bamboo fiber composite. And the bamboo fiber composite is also widely available to be purchased. Okay, so next, the government agency, which is the Civil Aviation Authority of Malaysia. So this glider design will help in maintaining the nation's competitive edge within the global aviation sector, which this glider design has the potential to be commercialized in the global sector and hence can improve the economic development in the country. Okay, we move to the environmental effect of the design. So the first environmental effect is the bamboo fiber. So the users of the bamboo fiber has paved a new, greener and more environmental friendly future, especially in manufacturing industries. So with a higher growth rate, the bamboo plant actually covered approximately 3.2% of the world total forest area, which it will ensure a continuous supply for the raw material. So this bamboo fiber, it reduces the pollution as the bamboo plant is able to reduce the carbon dioxide content. So the bamboo-based composite is biodegradable, which means the bamboo composite will break down and blend back with the earth into its original component. The next is the carbon fiber environmental effect. So carbon fiber is actually a thermoset material, which means it cannot return to its original state. Okay, So the engineer has invented recycling methods for carbon fiber composite recycling, which means the recycled carbon fiber can replace the short virgin fibers into non-structural applications. Okay, so that's all from our group. And if you have any questions, you can ask in the chat box or unmute your mic and ask any of our team members. Okay, thank you.